Since the dawn of civilization, humanity has looked to the heavens, not only to measure time, but to understand it. Time has always been the invisible river carrying us forward. But what if that river could be navigated? From the movement of the stars to the ticking of the clock, humanity has sought to understand time's flow.
To move faster is to move slower through time. A journey aboard a near light-speed ship could mean centuries pass on Earth, while only years pass for the traveler.
Imagine a tunnel through space and time, a bridge connecting two distant corners of the cosmos. Scientists call it a wormhole. Have you ever looked up at the night sky, at a single star twinkling millions of light years away, and wished you just could go there? Ah, not in a spaceship that takes generations, but right now in an instant. The universe is unimaginably fast, a cosmic ocean of staggering distances. Our fastest rockets are like snails crossing the Continental. But what if there is a secret passage, a hidden door in the fabric of space-time itself? This is the grand and tantalizing idea of a wormhole.
In 1935, Albert Einstein and Nathan Rosen proposed the existence of such a bridge, a shortcut through space-time now known as the Einstein-Rosen bridge.
Yet nature is not so generous. Wormholes would collapse instantly before anything could pass through, unless we could hold them open with exotic matter, a substance with negative energy. If we could stabilize such a wormhole, it might become a true time machine, allowing travel not just across space, but across time itself. Einstein discovered that time is not universal. For the traveler moving near the speed of light, time itself slows down. A window into the future.
This is Einstein's time dilation formula from special relativity. It shows how time slows down for an object moving at high speed. T prime, T dash, the time measured by the moving observer on the spaceship. T, the time measured by a stationary observer on Earth. V, the speed of the moving object. C, the speed of light, approximately 300,000 kilometers per second.
In short, the faster you move, the slower time passes for you. Example, if a spaceship travels near the speed of light, 1 hour for the astronaut might equal many years on Earth. Every astronaut who circles the Earth lives this reality. Moving fast in orbit, they age slightly less than those who remain below. The difference, only fractions of a second. Yet it proves that time can be stretched. Near a black hole, gravity grows infinite. Time itself begins to stretch. For the traveler falling inward, only moments pass, but for the universe outside, eternity unfolds. Here at the edge of time, even light cannot escape. For centuries, we've looked at the stars and wondered if time could ever flow in reverse. Einstein showed us that time bends. Perhaps it could even fold. A bridge across time, a wormhole, might connect today with yesterday.
But traveling to the past raises a paradox, the grandfather paradox. If you went back and changed something that led to your birth, would you still exist? Could a single action erase an entire timeline? But physics may protect its own logic. The Novikov self-consistency principle suggests that paradoxes cannot exist. Every event that happens was always part of history, and no traveler can change what was destined to be. If time travel to the past is possible, then the events that happen must be self-consistent. In simpler terms, you can't change the past. Anything you do while in the past was already part of history. Therefore, no paradoxes, like killing your past self or preventing your birth, can ever happen, because the universe corrects itself to stay logically consistent. Imagine you travel back in time and try to stop your grandfather from meeting your grandmother, meaning you would never be born. But if you were never born, you couldn't go back in time to stop them. That's a paradox. The Novikov principle says this paradox can't occur because the laws of physics prevent it. In other words, you can interact with the past, but you cannot change it.
But if one cannot change the past, perhaps each decision creates a new reality. Every choice, every step, could give birth to another universe, a multiverse of possibilities. Yet perhaps nature prevents such journeys altogether. Stephen Hawking proposed the chronology protection conjecture, that the universe forbids time loops to safeguard causality itself.
It suggests that the laws of physics prevent time travel into the past in order to protect the consistency of cause and effect, meaning the universe itself protects its timeline from paradoxes.
If time travel to the past remains forbidden, what remains is understanding time itself, not as a line, but a landscape. We move through it every day, one moment at a time.
Maybe time travel was never meant to be conquered, only understood. And in understanding it, we glimpse our own fragility and our place within eternity. Time. It doesn't only pass, it shapes us. Each second leaves a mark. Each memory a ripple. We think of time as something we move through. But perhaps it's time that moves through us.
Memory is humanity's first time machine. Carried not by technology, but by the mind itself. We travel backward every day into moments of joy, regret, or loss.
But what if we could return, not to change, but to understand? To see the past not as a wound, but as a teacher? Perhaps real-time travel is not about movement, but acceptance.
Time heals not by erasing, but by revealing what remains. To live in time is to embrace change and to find peace in the passing of moments. Every decision we make divides reality. Every yes or no echoes into new worlds. The multiverse, infinite realities born from infinite choices.
In one universe, you're here watching this moment. In another, you turned away. In countless others, the story unfolded differently. But somewhere, it always led you here.
Maybe we are not bound by one timeline, but part of a greater cosmic pattern. One where every version of us explores a different path toward the same truth.
If every possibility exists, then perhaps every loss is also a continuation. Somewhere, another version of you keeps walking forward, still searching, still learning. Stephen Hawking once asked, if time travel were possible, where are the visitors from the future?
Hawking's question was never about proof, but wonder. What if the silence of the future is the universe's way of protecting time itself? Perhaps time travel is not about machines or equations, but about understanding the story we are already part of. We are travelers, not through wormholes, but through moments. Every second we live is a step into the unknown. Every memory a footprint left in eternity. Time may never let us change the past, but it grants us something even greater. The chance to shape the future, one heartbeat, one thought, one act of courage at a time. Maybe that's the real journey through time, not to escape it, but to embrace it. Thanks for watching. If you enjoyed exploring this what if, hit like, subscribe, and let me know in the comments, what's your dream underwater superpower?